Some quick refreshers before we start reviewing for this final. Factoring, you know this is one of the super important skills in all your math classes. Being able to factor trinomials, polynomials. You always look for a greatest common factor first. So if you look at 40x squared plus 32x plus 6, can you think of a number that goes into all of those? Yeah, 2. So we'll factor out the 2 first. Let's see what we got after that. 2 times 20x squared. 2 times 16x would be 32x. And 2 times 3 would give us 6. Now that 2 on the outside, that kind of just hangs out until our final answer. Now there are a couple ways you can factor this trinomial. I'll show you the way I think is easiest, cleanest, bestest, but it is not the only way. But you can multiply first and last, which you would need to do the other way too. I'll show you that. 20 times positive 3 is positive 60. Now we're looking for factors of 60 that add up to 16 here. So you might be like, all right, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, or 6 times 10. Which set adds up to 16? Oh, 6 and 10. Now, ordinarily, positive numbers that add up to positive 16, they would have to both be plus, right? So you would just say x plus 10, x plus 6. But if you were to FOIL that out, it wouldn't give you 20x squared plus 16x plus 3. So there's one more step when you're factoring and there's that number in front of the x squared. You have to try to divide them by that number. So we're going to try to divide both of these by 20. Now, neither of those can be divided by 20, but we can simplify both of those fractions. So 10/20ths becomes 1/2. Whatever you have in the denominator, you just move to the front. Make it 2x plus 1. Same thing here, 6 and 20. If you simplify that, that would be 3/10. And then the 10 moves to the front, 10x plus 3. That's what I think is the most efficient way to factor those kind of problems. Now, there is another way that'll give you the same answers, and it's got a lot of the same steps. You get the 2 on the outside. You still multiply the 20 times 3 to get that 60. Find factors of 60 that add up to 16. So here's where the steps would differ. And you'll see we're going to get the same answer here. So we split this 16x into 6x and 10x. And it doesn't matter which one you write first. We bring down the other stuff, the 20x squared and the plus 3, and we factor each half here. So we factor out our greatest common factor. For 20x squared and 6x, the biggest thing they have in common is 2x. So if we factor out 2x, that would leave us with 10x plus 3. On the right side, the only thing that 10x and 3 have in common is a 1. So if you factor out a 1, you're left with 10x plus 3. If you look at both parentheses, oh my gosh, they have a 10x plus 3. That would show up in the answer. Oh, 10x plus 3. The other part is the common factors that we factored out. 2x plus 1. What? It's still there. It still gets you there. Whichever way works for you, do it that way. Also, keep in mind this is a multiple choice test. So worst case scenario, if you forget, you could always FOIL out the answers and see which one gives you whatever was in the question. All right, number 2, 2x squared minus 72. Do they have a common factor? Yeah, 2. So if you factor out a 2, you're left with 1x squared minus 36. And that's a difference of squares, a very common thing. When you're factoring a difference of squares, where you have two things you could square root and there's a minus in the middle, you square root them both, you put one with a plus and one with a minus. The square root of x squared is x. The square root of 36 is 6. So that would be your final answer. Oh man, too much fun. We got a couple more. 2x squared minus 20x plus 42. A greatest common factor would be 2. So if you factor out a 2, we're essentially dividing each of these big numbers by 2 here. So that would make it 1x squared minus 10x plus 21. Now the nice thing about this is in front of the x squared is a 1. So kind of go straight to the final answer here. If they multiply to a positive, that means they both have to be plus or they both have to be minus. But if they're going to add up to negative 10, they would have to both be minus. X minus, X minus. So if we're thinking factors of 21, our options are 1 and 21 or 3 and 7. The set that adds up to 10 would be 3 and 7. Yes! All right, last one. They have a common factor of 2. They're all even numbers here. So we'll factor out the 2, which leaves us with 36x squared plus 12x plus 1. Now, I intentionally put this in here because it's one of the special case factoring things. But even if you didn't know that, you could do 36 times 1, which is 36, and find the factors of 36 that add up to 12. It would be 6 and 6. Great, and that'll work. But a lot of times with these, if you can square root the first term and you can square root the last term, it's probably a perfect square kind of deal. So, the square root of 36x squared is 6x. The square root of 1 is 1. The symbol between them would always be whatever symbol's first, because the last one would be plus either way. If it was a negative times negative, that would end in plus. If it was positive times positive, that would be in plus. This is the final factor form. But if you're like, can we do that every time we could square root the first and last term? Not necessarily. The middle term is what you want to check, this 12x. That's what you should get if you multiply the two terms together and then multiply by 2. 6x times 1 is 6x, times 2 is 12x. So it does work out. But again, if you're worried about shortcut stuff, you could find the factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. You need the set that adds up to 12. That would be 6 and 6. So it would look like this: 2x plus 6, x plus 6. But we'd have to try to divide them by the number in front, the 36. Neither of those can be divided by 36, but both fractions would simplify to 1 over 6. And the 6's would come to the front. So you'd have 2 times 6x plus 1 times 6x plus 1. And since they are the same thing, you would make that 6x plus 1 squared. So I know these are pretty complicated problems I chose. I kind of chose upper level for the review so that maybe the assignment will feel a little easier and then the actual final exam will feel very easy. All right, expanding logarithms. When you are expanding logarithms, each one of these things is going to have a base of 2. So the property is, if things are being multiplied and you're expanding them, then you separate them with addition. So like here, the 16 times x to the third. So we're going to split that. We're going to make it log sub 2 16 plus log sub 2 x to the third. A couple other properties here. Now, logarithms are saying like, this part here is essentially you're trying to figure out 2 to the what power is 16. And maybe you can't do it, but 2 to the 4th power is 16. So this would just simplify to just 4. Not 2 to the 4th, not anything else except for just 4. Great. The other thing is, when you have an exponent, you bring it out in front. So this would say plus 3 log 2x. That would be as much simplifying as we can do. It'll click back in. You guys did great with the logarithms back in the day. So multiplication, when you expand it, comes out as addition. If it's division, that would show up as subtraction. So this has some of everything. So up top we have multiplication, so there'll be a plus. The only thing being divided would be the 27, so that will get a minus. So let's stretch it out. We have log 3, 4 plus log 3x squared. And then the 27 is being divided, so we'll say minus log 327. Now, can you simplify? Does 3 to any exponent come 4? No, so you can't simplify that, you just leave it. Log 3, 4. Here we're going to take the exponent, bring it out front, so plus 2 log 3x. And then this last one, you can simplify this. If you had an equation 3 to the something power equals 27, that's 3 to the 3rd power. So back here just simplifies to 3. So that's expanding. Condensing is the opposite of that. You're going to see it stretched out like this, and you're going to mash it down. So when you see addition and you're bringing it together, you're going to multiply. If you see subtraction and you're bringing it together, you're going to divide it. So here, woo! And we have the numbers out in front. Wow, remember that comes back as an exponent. So this would be like log 2x to the 6th plus log 2x to the 3rd. Now we're bringing these together, we're condensing it into one single logarithm because they both have a base of 2, so we can do that. So that means when we condense it and it has addition between them, we're going to multiply these. Now if you remember from your exponent properties back in the day, probably algebra 1, when you do x to the 6th times x to the 3rd, you add the exponents. So that would be x to the 9th. So this would be our final condensed answer. It's a doozy. So we're condensing this one, there's subtraction in the middle, so when we bring it together as a single logarithm, we're going to do 80 divided by 5. Now 80 divided by 5 is 16, and that would ordinarily be done. However, if you're thinking in your head of an equation 4 to the something power equals 16, that's 4 to the 2nd power. So this would just come out to 2. That would be your final answer. How cute was that? Huh? I think we got some equations with logarithms next. Change of base formula. I gotta get a calculator for this. Oh my gosh, this is so me unprepared. Come on now. So what I was just saying is like, we're trying to figure out 3 to the something power gives us 30. And like 3 to the 3rd is 27. 3 to the 4th is 81. Ugh, I can't get 30. It'll be between 3 and 4. So what you can do is the change of base formula. Really all you have to do is, we're going to change them both to base 10, which means you don't even write anything in the subspot. But you're going to write log of the number written large over log of the number in the subspot. Again, these are now both base 10. When there's nothing written in logarithms, it's an invisible 10. But you're able to put this into your calculator. So let me see, it's been a while since I logged. If I do log 30 divided by log of 3, we get 3.0959. So let's call it let's go to 3 decimal spots here, 096. Which again, makes sense because 3 to the 3rd power is 27. This is just a little bit above that. So here, 4, you can't get 4 in the 13, so we just say log of 13 over log of 4. You do that in your calculator. Log 13 divided by log 4. And I got 1.850. Usually they have you round it off to the 3rd decimal spot there. So I know that's 1.85, but we're going to go to that 1000th spot. All right, cool. Now it wants us to use some mental math to evaluate. So again, we're trying to figure out like 1/2 to the something power will give us 16. So what we can do is we can change them to get a common base. The last one we couldn't do that. It was change of base. We couldn't get a common base. But these could both have a base of 2. Like 16 is 2 to the 4th power. 1 over 2 is just 2 to the negative 1st power. And once you're set up like that, then you're just solving the exponents. Once you have that common base of 2, we're just solving the equation negative 1x equals 4, which all we care about is the -4. If you circle the x, that's fine, it's the same thing. But we kind of put in the x ourselves, that's why I wouldn't, it's just -4. So here, we're saying 7 to the something power equals 1. What the heck? Common base? I remember that. Anything to the 0 power equals 1. So it's just 0. Anytime you have a 1 in the big spot, it just comes out to 0 because anything to the 0 power equals +1. All right, we got some logarithmic and exponential equations. Now, if you look here, we have exponents on both sides. We can get a common base, 10 and 100. We could make 100 10 to the 2nd power. So let's do that. So let's see, on the left, we have 10 to the x minus 3rd. On the right, I'm gonna change 100 to 10 to the 2nd, and then to the 4x minus 5. Again, we have that common base of 10, so we're just solving the exponents. So over here I have x minus 3. Over here though, remember when you go power to power, again this is old algebra properties, you multiply the exponents. So that would be 8x minus 10. And now we're solving a regular equation. We can subtract an x from both sides. -3 equals 7x minus 10. Okay. Add the 10 to both sides. 7 equals 7x, and then you would just divide by 7, and you get 1 for x. Now the nice thing about these is you could substitute that 1 back in and make sure it's correct. Like 10 to the 1 minus 3 is -2. We're going to make sure that's equal to 100 to the, let's see, 4 times 1 is 4, minus 5 is -1. Ooh. If I was to rewrite 10 to the -2nd, that's 1 over 10 squared. If I was to rewrite 100 to the -1st, that's 1 over 100. And look, 10 squared is 100, so it's 1 over 100 equals 1 over 100. Oh my gosh. All right. Number 14 is an exponential equation. So we're going to have to isolate the base with the exponent, meaning I got to get rid of that +3. It's just the loose +3, so we can subtract 3 on both sides. We'll have 10 to the 2x equals 5. Now what we're going to do is we're going to log both sides. So we can, if you're changing both sides of the equation evenly, you can do whatever you want. But I'll show you why we're going to log both sides here. Because when you do a logarithm like that, that will allow us to take the exponent, which we're solving for, and move it out front. So this would be like 2x times log 10 equals log 5. Now this one's kind of special because of the log 10, but let's pretend like you didn't know that. Log 10 is equal to 1, right? Because 10 to the first power is 1. But again, pretend you didn't remember that. It's multiplication here, so you can just divide it on both sides. So we'd have 2x equals, oh shoot, I wrote log 5 over here. It should have been log 10. Log 5 divided by log 10. 5 divided by log 10. We have 0.699 if we're rounding. And that's equal to 2x. So then you would just have to divide by 2. And I got 0.39349. And I can't read numbers today. 0.349. All right, cool. So when you have a base that you're trying to cancel out, you can log both sides. On this one, we have log sub 8 on both sides. So what you can do is you can bring in a common base. Because there's a property where if you have 8 and the exponent is log sub 8, all that stuff cancels out. So this 8 to the log 8, all that goes away on both sides. So we're just left with 11 minus 6x equals 1 minus x. So we can add 6 x's to both sides now. 11 equals 1 plus 5x. And you can subtract 1 from both sides. 10 equals 5x, and then we'll divide by 5, and you know it's 2. You know it. 2 equals x. Logarithms, you remember them, you love them, they were a true delight. I forget if that's the last slide, it is.